Welcome back to my Commodore 64 Memories videos. This is where I look at old Commodore 64 software and some of the technical details behind them. Today we have Dropzone, released in 1984 by US Gold, created by Archer McLean. This game was requested by one of my YouTube viewers who added a comment to a recent video. Thank you very much for suggesting this game. It's a real old classic, and I'm surprised I haven't looked at this before now. This game is really very similar to Defender. It's got very similar sound effects and very similar game mechanics where you're scrolling around and shooting lots of enemies and trying to guard against the humans being abducted and also return them to their home. So we get back into this title screen sequence and this nice expanding kind of like folding out Dropzone logo that whizzes around the screen. We have lots of colours. I think we can see at the top there that there are some expanded sprites that scroll behind but with priority set so that the sprite colours introduce colour changes to the text. There's a lovely split effect there where the bottom logo drops away from the top, and then we have this nice colour cycling high score table revealed behind that. I think the first thing we can notice is that, oh look, most of the enemies that appear on the screen, not all of them, but most of them, don't seem to be using hardware sprites. The explosions as well don't seem to be using hardware sprites. And we know that because the C64 debug GUI will put these red bounding boxes around hardware sprites. So the player character, the bullets from the player character are hardware sprites, but these enemies whizzing around the screen are software sprites. The explosion particle effects are also software sprites. Well, you could call them software particles, I guess. They're kind of a little bit similar. They remind me a bit of the explosion effect in Whizball, right? That is really a lovely title screen intro there with the Dropzone logo scaling out. So let's have a look in the Vic debugging mode where we can move the targeting cursor around the screen and we can see what the current Vic state is. So we can definitely see there that it was using expanded sprites to introduce color to the logo. We have sprites being used there for the top part of the high score table, and then the rest of it is just characters. Okay. The sprite colors are being updated with a raster bar effect, so basically we're getting these scrolling colors coming down. Let's investigate this. So this is a surprise. I thought that this was using line crunch and FLD, flexible line distance, and also line crunching to do this logo expansion, but it's not. Look, it's just a standard screen mode. So I'm guessing that it's using hardware scrolling and also just scrolling the character screen around. But basically, it's just updating the character set, I think, dynamically to get the animation to work for the expanding logo. So that was a good surprise, right? Now in game, notice that when I move around, the screen and the character set pointers don't change. So that there's no double buffered screen or character set being used for the main part of the game display. That's an interesting point because it means that actually the game is really not scrolling much data at all. It's actually updating the character set information on the screen itself, the character information. The character set seems to be stationary. Now, let's have a look at the bottom here. Well, the landscape itself, if you look at the character set pointer values on the right-hand side there, as I move the targeting cursor up and down for each character set row, for the landscape, it's actually using a completely different character set. So the game is using what? 1, 2, 3, 4 character sets there. Is it 1, 2, 3, 4? Yeah, plus another one for the game display, plus another one, I think, for the status panel. So this current Vic bank here, well, actually, the status panel down at the bottom seems to be using another Vic bank, but the main game seems to be using Vic bank between 4000 in hex and 7FFF. And then the status panel seems to be using the next Vic bank up. But yeah, this game, the main game display, is certainly using a lot of Vic banks. The score status panel scrolling area is interesting. So the left and right portions of the map, little scanner map display down at the bottom, have opaque black sprites over the top of it. Right, so that means that the little edges to the left and to the right of the hardware scrolled area are obscured by the sprites. And then the characters are not extended to the full screen width. So basically there are some opaque sprites pretending to be narrower borders, if you like. But yeah, that's a really cool effect, because there are a good few sprites being used for the status panel, and there are some character rows as well being used for the score status panel. But yeah, the sprites are really quite well obscuring the areas, the edges of the hardware scrolled status panel map display there. You can see it quite clearly now if I switch off the sprites and I remove the sprite frames. There you go. You can see what are just characters there now in the debug view for the score status panel as I move around, because the sprites are not obscuring anything. Now in ICU C64, you can see on the debug graphics map view there how it's just basically nice characters moving around. Now let's go into the character set view. Now we have the character set debug graphics map view open, and I'm pausing and advancing each frame, so you can see when the logo is quite narrow vertically, there isn't much character set information, and then as I advance the frames and the logo gets wider, more character set information is being added dynamically to the character set. So this means that actually the game is definitely kind of like calculating this expanding logo dynamically into the character set, which is a really cool way of doing it. I really do like that. It's a really good effect. So let's save a snapshot now. We're in the game. In the character set view now for the game, if we go back to the character set, there we go. We can see how much of the Vic bank is full with the character set. The landscape character sets take up a vast majority of the Vic bank. And we also have the character set data for the enemies on the screen and everything else. But look, they're not dynamically updating, apart from the 500 score updating, flashing away all the time. There's no real dynamic characters being updated. So that means actually that the movement of the enemies are basically like pre-calculated character frames, and it's just moving them around like character objects. So there's no real dynamically updated characters for the software sprites. It's just basically pre-calculated, kind of like software sprite frames. It's even less of a software sprite because there's no masking calculations going on or anything like that. We can see there in the character set, in the text screen view, sorry, we can see how the characters just have this repeating pattern of characters. And that's for the landscape, and that's because the different rows of the landscape there use those different character sets. There we go. So we can see when we move around with the character set views, we can see all of the different character sets that are being used for the landscape rows for the game display. When I was playing, I noticed this rain cloud as well. Look, the rain particle effects coming down are actually dynamically updated into the sprite frames. There are 3 sprite frames there with the rain falling down. It looks like a really nice effect. There's tons of polish in this game, right? The cloud also shoots sprite-based lightning as well, and those lightning frames are in the sprite sheet as well. So this game really is using a good mixture of software sprite-based characters effects and also hardware sprite effects. I really do like the particle effects for the explosions. They really are fantastic. One other thing I wanted to highlight was looking at this debug memory map here for the execution and also read and write updates. Look, if I zoom in to this part of the memory map, you can see that the entire game map area seems to be updating with respect to what the enemies are doing, especially for the area that's visible on the screen at the time. So if I scroll around, look, you can see that different areas of the horizontal map area in memory are being read and written to. What this tells me is that the map is basically 256 bytes wide, and probably that many number of bytes high for the screen, obviously. But basically the enemies, according to this sliding window through the map, right, the enemies are being updated for this visible area. Let's change the view so that instead of events, let's make it show values. There we go. And this is read and write. There we go. The grey one is basically values. So let's go back. It's number 2, right? So I'm not interested in changes. I'm interested in what the values are. So each different value in the memory has a different color in grayscale anyway. And this tells us that the game is quite consistently updating values in the kind of like same kind of like range, if you like. So I think that this is a huge, great big kind of like virtually windowed map into a 256 byte wide game map for the enemies. And I think the game is prioritizing the updates for what would be visible on the screen, and then kind of like updating the areas on the screen where those enemies update from inside the great big map. But yeah, look at that. So when there are explosions and stuff like that, you'll notice that there are large kind of like sparkles being updated into the great big virtual game map as well, and the bullets, the enemies certainly. Let's move around a bit. You can see there, look, that there's a little area being used for the humans or whatever they are that you have to rescue down at the bottom of the screen. Yeah, really great. I mean, I really do like that kind of thing when you can see that in game. So the explosion affects all of the enemies and everything like that. Let's move it. There we go. Wow, there's certainly quite a lot of memory updates going on. But the game only really needs to scroll the 4 character rows for the landscape, right? So that's actually not too bad. The rest of the game can be dedicated into updating the enemy graphics, which mostly use characters, but also some hardware sprites. So that's how this game is actually so quick. And I think the repeated reads in vertical columns there that we can see in green, I think what that indicates is that the enemies are probably vertically scanning to see if there's anything to shoot at or anything to pick up, like the humans, right? The enemies are probably scanning the humans potentially, or scanning. Scanning for humans, I expect, to see if they can pick up any. And that's what those repeated green reads probably are. Not every enemy can pick up humans. I think it's just the green kind of like blobby enemies. So they're probably the ones doing the green reads, the repeated ones. There are some writes too, of course, where it's updating what the visible enemies are doing inside the map. But yeah, look at those particle explosions going on. They're reads and writes. The writes are yellow, the reads are green, if I remember rightly. But yeah, when you shoot something like a great big yellow written updates for the particle effects. Fantastic. I love this kind of like view in the memory view. It really helps you to, or helps me anyway, to understand the high level structure and flow of the game logic. So this game uses quite a lot of dynamic characters effects, some hardware sprites, quite a lot of software based sprites, and also several different character sets. So I hope you found this kind of like technical deep dive into this game interesting, and yes, thank you again for suggesting this game to have a look at. If you have any other game suggestions, then please do add them to the video comment section below. So yes, if you like these kind of technical deep dive videos, then please do consider liking or subscribing to this channel, or sending me a super thanks. They are always very much appreciated. Take care, have a great day, evening or night, wherever you are.